Okay, here we go with, this is well, very much a forces and an energy question. We're looking at an object of mass m with speed v, and it's colliding, and we know they stick together. We want to know the change in the kinetic energy. All right, let's go for it. We want to know the change in kinetic energy. So first things first here, we're not really told it's an elastic collision or not. However, if it was elastic, then the answer would be A. I think from experience we can tell this is not going to be A. We're expecting one of these B, C, or D. Let's go for it. Let's firstly remember that our initial kinetic energy is a half mv squared. Okay, and our final kinetic energy is going to be a sum of the two kinetic energies. Now in this case, they move off together, so they both have the same mass, and so therefore we've got a half m times x squared plus half mx squared, m capital X squared. X here is just this unknown speed that we don't know. How are we going to find out that speed? Well, you're going to use conservation of momentum because we are assuming here no forces acting on here. We have initially a mass traveling at velocity v, and finally two masses sharing the same velocity, x and x, because they move together. And so therefore, x is equal to v over 2. So basically you've got 10 meters a second coming into 5 meters per second, etc. When they stick together and they've got the same mass, that's crucial here, only when they have the same mass, the speed simply halves. Now, why is that important? Well, we can now start to work out our final kinetic energy, mx squared. Well, that's mv over 2 squared, noticing the v and the 2 both get squared, so we've got an mv squared over 4. We started with half mv squared, we've ended with mv squared over 4, and so therefore we'll find the difference between the final and the initial to get mv squared over 4, which is equal to c. I'm so glad I don't have to say mv squared over 4 again because I've said it a lot. Whoops, that skipped on. Okay, hopefully you can see the process there. All right, I've seen similar questions again where you've been asked to calculate the speed or maybe the percentage difference, that kind of thing. This is a test of your understanding of conservation of momentum and energy transforms.